This is SpaceTime Series 28, Episode 26, for broadcast on the 28th of February 2025. Coming up on SpaceTime, samples from the asteroid Ryugu provide more evidence of salty water in the outer solar system. Europe's solar orbiter spacecraft about to undertake a close encounter with Venus. And NASA's polar ice experiment paves the way for future manned missions to the Moon. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Following the recent discovery of salts in samples from the asteroid Bennu, scientists have now also detected signs of salt water, or at least the remnants left by it, on the asteroid Ryugu. While Bennu was the target of NASA's OSIRIS-REx sample return mission, the 900-metre-wide Ryugu asteroid was visited by Japan's Hayabusa 2 sample return mission. Like Bennu, Ryugu is a near-Earth Apollo group asteroid. Scientists at Kyoto University have found evidence of mineral salts in the samples they recovered from Ryugu during the initial phase of the Hayabusa 2 mission. The discovery includes deposits containing sodium carbonate, halite and sodium sulfates, suggesting that liquid saline water once existed within a parent body from which Ryugu emerged. The authors expected that the grains returned from the asteroid might contain substances not generally found in meteorites. They anticipated that these could be highly water-soluble minerals, which readily react with moisture in Earth's atmosphere and are therefore difficult to detect unless examined in their pristine state as preserved in the vacuum of space. One of the study's authors, Toru Matsumoto, says careful handling allowed researchers to identify the delicate salt minerals, providing a unique glimpse into Ryugu's chemical history. Matsumoto says the asteroid may have once been part of a larger parent body that probably existed around 4.5 billion years ago, shortly after the formation of the solar system. And that parent body would have been heated by radioactive decay, creating an environment where hot water could exist. While Ryugu and its grains didn't actually contain any moisture, questions remain about how the liquid water would have been lost. Matsumoto says these crystals are showing how liquid water disappeared from Ryugu's parent body. The salt crystals dissolved easily in water, suggesting they could only have precipitated within a highly saline water solution and in conditions with a limited amount of liquid. Matsumoto and colleagues hypothesized that as fractures exposed the salt water to space, or as the parent body cooled, the liquid could have either evaporated, sublimated, or froze, and the mineral salts are the crystallized remains of that water. The deposits could prove crucial in comparing the evolved water on the dwarf planet Ceres, located in the main asteroid belt, and on the moons of Jupiter and Saturn, since scientists believe these icy bodies harbour subsurface oceans or liquid reservoirs. They expect sodium carbonate and halite will be found in surface deposits on Ceres, in water plumes from the Saturnian ice moon Enceladus, and on the surfaces of the Jovian Galilean moons Europa and Ganymede. Since salt production is closely linked to the geological settings and brine chemistry in these aqueous bodies, the discovery of sodium salts in the Ryugu samples provide new insights for comparing the role water has played in the development of planets and moons throughout the outer solar system. This is SpaceTime. Still to come, Europe's solar orbiter spacecraft undertaking a close encounter with Venus, and NASA's polar ice experiment paving the way for future manned missions to the Moon. All that and more still to come on SpaceTime. European Space Agency is now guiding its solar orbiter spacecraft through its closest ever encounter with the planet Venus. The flyby will be the first to significantly tilt the spacecraft's orbit, allowing it to see the Sun's polar regions for the first time. You see, the Sun's poles are not visible from the Earth. And studying these polar regions of our nearest star will improve our understanding of solar activity, space weather, and the Sun-Earth connection. Since its launch back in 2020, solar orbiters carried out a number of gravity-assist flybys using both the Earth and Venus to gradually shrink its orbit, bringing it closer and closer to the Sun. During this encounter, the spacecraft will fly just 379 kilometres above Venus's surface. ESA flight dynamics expert Julia Schwartz says getting so close to Venus allows scientists to use its gravity to significantly change the spacecraft's orbit without using lots of fuel. Our planets all orbit the Sun on roughly the same flat plane, called the ecliptic, and for a spacecraft to get away from that ecliptic requires a great deal of fuel. Solar Orbiter will get around that problem by using Venus as a gravity assist, slingshotting itself into a slightly different angle with respect to the ecliptic. And that will eventually give the probe a much better view of the Sun's polar regions. Future Venus flybys, such as one slated for December 2026, will further tilt the spacecraft's orbit, enabling high-resolution imaging of the Sun's entire polar regions. From this unique orbit, the mission will help scientists refine their understanding of solar activity and improve their ability to safeguard technology on Earth from powerful solar storms and erratic space weather events. But passing so close to Venus in order to get this gravity assist presents a number of challenges for mission managers at ESA's European Space Operations Centre in Darmstadt, Germany. Precise calculations and minor course corrections will be necessary before and after each flyby in order to keep the spacecraft on track. The flyby has been carefully planned to get as close to Venus as possible in order to get the most out of the encounter, while at the same time keeping the spacecraft safely above the planet's atmosphere in order to avoid experiencing atmospheric drag. But Solar Orbiter will still be bathed in thermal radiation emitted by the planet as it swings past. Mission managers are expecting the spacecraft to heat up significantly during the flyby, and to prepare for this, they've carried out a detailed simulation of the heating effect of Venus's gravity assist manoeuvre. While it shows that several parts of the spacecraft will experience a significant temperature increase, all components should stay well within their design limits. During the manoeuvre, Solar Orbiter will continue to point its instruments and, more importantly, its heat shield towards the Sun to keep the spacecraft safe. Of course, this means it won't be able to point any of its cameras towards Venus and its cloud tops during the flyby, but it will still have an opportunity to gather some scientific data. See, unlike the Earth, Venus lacks a global magnetic field to interact with the charged particles flowing from the Sun and the solar wind. But there's a layer of the Venusian atmosphere known as the ionosphere which interacts with the solar wind in rather unique ways. Solar Orbiter's magnetometer and radio and plasma wave sensors will be switched on as the spacecraft passes Venus, allowing it to record the planet's magnetic and plasma environment. The data they collect will contribute to ongoing research on how the solar wind affects planetary atmospheres beyond Earth. Mind you, Solar Orbiter isn't the only ESA mission visiting Venus this year. ESA's JUICE spacecraft, which is on its way to Jupiter to explore its icy moons, will also fly past the planet in August. Solar Orbiter and JUICE will pass Venus just 194 days apart. That's less than one Venusian day, which lasts 243 Earth days. The frequent visits highlight the planet's important role as a waypoint for ESA's interplanetary voyages. However, while Solar Orbiter and JUICE are making just brief visits to Earth's neighbouring planet, for some ESA missions, Venus is the final destination. From arrival in 2006 until the end of the mission in 2014, ESA's Venus Express spacecraft studied the planet's atmosphere and clouds in detail and also mapped its surface temperatures. Looking ahead, ESA's Envision mission is set to launch in the early 2030s. Envision will be the first mission to provide a comprehensive view of Venus from its inner core right through to its upper atmosphere. In doing so, it will help scientists determine how and why, despite starting off similar, Venus and Earth have evolved in such different ways. This is SpaceTime. Still to come, NASA's Polar Ice Experiment paves the way for future manned missions to the Moon, and later in the Science Report, claims that night owls have a higher likelihood of developing type 2 diabetes. All that and more still to come on SpaceTime. NASA's Polar Resources Ice Mining Experiment 1 or Prime 1 mission will explore the Moon's subsurface and analyse where lunar resources may reside. The experiment's two key instruments will extract and analyse lunar soil in order to better understand the lunar environment and subsurface resources, in the process paving the way for sustainable human exploration under the agency's Artemis campaign. The scientific instruments will work in tandem. The regolith, an ice drill for exploring new terrains, or Trident instrument, will drill deep into the Moon's surface in order to collect samples. while the mass spectrometer observing lunar operations package will analyse these samples to determine the gas composition released across the sampling depth. Prime 1 project manager Jackie Quinn from NASA's Kennedy Space Center in Florida says the ability to drill and analyse samples at the same time allows scientists to gather new insights into what will shape the future of lunar resource utilisation. You see, human exploration of the moon and deep space will depend on making good use of local resources in order to produce the life-sustaining supplies needed to live and work for periods of time on other planetary bodies. The Prime 1 experiment is one of NASA's payloads aboard the next lunar delivery through NASA's Commercial Lunar Payload Services Initiative, which is set to launch from the agency's Kennedy Space Center this week aboard the Intuitive Machines Athena lunar lander, which will explore the lunar soil in Mons Mouton, a lunar plateau near the moon's south pole. Developed by Blue Origin, Trident is a rotary percussive drill designed to excavate lunar regolith and subsurface material up to 1 metre deep. The drill will extract samples, each about 10 centimetres in length, allowing scientists to analyse how trapped and frozen gases are distributed at different depths below the surface. The Trident drill is equipped with carbide-cutting teeth designed to penetrate even the toughest lunar materials. Unlike previous lunar drills used by the astronauts during the Apollo missions, Trident will be controlled from Earth. The drill may provide key information about subsurface soil temperatures, as well as gain insight into the mechanical properties of the lunar South Pole soil. Learning more about the regolith's temperatures and properties should greatly improve science's understanding of the local environment and where lunar resources may be stable, in the process revealing what resources may be available for future missions. A commercial off-the-shelf spectrometer will then analyse any gas released from the Trident drill samples, looking for the potential presence of water ice and gases trapped beneath the surface. Quinn says these measurements will help scientists better understand the moon's potential for resource utilisation.
When we eventually build infrastructure to enable sustained human presence on the moon, we're going to need some of the engineering data that Prime 1 will provide. Prime 1 stands for Polar Resource Ice Mining Experiment 1, and Prime 1 is a payload that's manifested and integrated onto the Intuitive Machines' second lunar lander, Athena. Prime 1 is comprised of 2 instruments, a drill and a mass spectrometer. The drill is called Trident. The Trident drill has the ability to take a sample from depth and bring it to the surface for evaluation by the accompanying instrument, M-Solo. M-Solo is a commercially manufactured mass spectrometer that has been ruggedized for spaceflight. Collectively, these 2 instruments will analyze across discrete depths lunar soil and tell us what gases are located at depth down to 1 meter. We're also going to get some very interesting geotechnical data from the Trident drill. All of the data that's gleaned from either M-Solo or Trident will inform future Artemis missions as they look to design habitation capability, long-term sustained presence on the lunar surface.
That's NASA's Prime 1 project manager, Jackie Quinn. And this is SpaceTime. And time now to take another brief look at some of the other stories making news in science this week with a science report. New research presented at the annual meeting of the European Association for the Study of Diabetes suggests that being a night owl could put you at a higher likelihood of developing type 2 diabetes, and it's not because of an unhealthy lifestyle. The authors looked into data of over 5,000 people and found night owls had higher body mass indexes, larger waists, more hidden body fat, and were almost 50% more likely to develop type 2 diabetes. The authors separated participants into 3 bedtime categories and find those who had the latest bedtimes were most at risk. A new study warns that glaciers worldwide are now losing ice at a faster rate, with ice loss increasing 36% over the last 10 years compared to the previous decade. The findings, reported in the journal Nature, are based on a huge global effort to track glacier melting. The study found that since the year 2000, glaciers globally have lost around 5% of their ice, but in some regions the ice loss has been as much as 39%. In New Zealand, glaciers have lost an average of 29% of glacial mass. The authors say that this global glacier mass loss is around 18% larger than the total loss of ice from the Greenland ice sheet and more than twice that of the Antarctic ice sheet. They warned that the planet's now facing continued and possibly accelerated mass loss from glaciers until the end of the century, and that underpins the call for urgent concrete actions to reduce greenhouse gas emissions. A new study has found that dogs trained to use soundboards to talk to people are capable of making two-word button combinations that go beyond random behaviour or simple imitation of their owners. The findings, published in the journal Scientific Reports, analysed data from 152 dogs over 21 months, capturing more than 260,000 button presses, 195 of which were made by dogs themselves. The findings revealed that the dogs were pressing buttons purposely to express their desires and needs, and not just imitating what their owners were doing. And it seems when dogs combine two buttons, the sequences weren't random, but were instead designed to reflect a specific request. The study observed that the buttons most commonly used were related to essential needs, with words such as outside, treat, play, and potty. Notably, combinations of words like outside plus potty or food and water were used in meaningful ways, occurring much more frequently than what would be expected simply by random chance. The Australian Medical Association has urged local councils to reintroduce fluoride to water supplies amid rising incidents of oral disease. Fluoride's been shown to help prevent cavities by making tooth enamel more resistant to acids from bacteria in your mouth. The Australian Drinking Water Guidelines recommend 3 compounds for fluoridating water: sodium fluoride, sodium fluorosilicates, and fluorosilicic acid. Usually one of these compounds is added under carefully monitored conditions during drinking water treatment before it's sent to the tap. Today, around 90% of Australians access fluoridated water at levels of between 0.6 and 1.1 milligrams per litre. And this is estimated to have reduced tooth decay in Australia by up to 44%. But it really depends on where you live, as there are different policies in different states and territories. For example, around 28% of Queenslanders do not have access to fluoridated water. Tim Mendham from Australian Skeptics says its benefits for oral health have been scientifically proven, and it's concerning that some local government bodies seem to be bowing to uninformed pressure groups.
All the evidence points to that fluoride being useful, cutting down on tooth decay, etc. I mean, you only need to look at kids in modern society in places where the water is fluoridated to know that they have a lot less fillings. The thing is, fluoride can be very natural. It's in rocks which water goes through, and they can be naturally fluoridated. And therefore, when your water authority fluoridates water, they have to assess how much is there already. And you don't want to overdose on fluoride. It can have a discolouring effect. Sometimes it has a scraping effect, etc. But in most cases, that's not doing that. It's not sort of at that level. The good side is a lot better than any sort of downside. But that hasn't stopped people sort of claiming that fluoride is an evil thing. It's going to sort of build up in your body and it's going to sort of cause you all sorts of diseases.
Apparently there was a study in 2019 claiming it was affecting the IQ of kids.
Yeah, and that was actually one study that was looked at very closely, and it was found to be pretty poor. Other people looked at it and said, no, there is no truth behind this thing. It's just a bad research. That's what you're supposed to do. You're supposed to assess other people's research. You put them up in the marketplace of scientific endeavour, and people then say, yeah, does it work, does it not work? Let's look at what you did. And in this particular case, they found out it wasn't very good. Fluoride's been added since the 40s in America, and ever since then in a lot of other places. Some places it's taken a long time to do it. Other times it stopped because of fear tactics by the anti-fluoride brigade, with some towns not doing it, and as soon as they stop doing it, the incidence of dental decay increases. It's a bit like vaccination. That you stop vaccinating people, and suddenly these diseases that should never exist anymore rise up again. So the same thing with tooth decay. You stop the fluoride works. It's simple as that. It works, and nothing is. If you have too much fluoride, it's not good for you. Anything it's the dosage which is the issue, and in fluoride's a very low dosage, but it has an effect.
Everything's a drug. It just depends on the amount you take.
That's right, yeah.
Dr. Carl told me that.
It is true. It's really true. I mean, sort of if you overdosed on, was it hydrogen dioxide?
Dihydrogen monoxide.
Yeah, dihydrogen monoxide, thank you. And you can overdose on dihydrogen monoxide. People say, oh, yeah, it's a chemical. I say, no, it's water. So, you couch it in particularly sort of scary terms, and anyone can believe it. But in this particular case, it's unfounded scare tactic, but it still exists. It's a simple thing to put in. Unfortunately, it's just as simple to stop.
That's Tim Mendham from Australian Skeptics. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.